So I'm going to start off this video by reading the problem. You're going to mow the lawn. Your lawnmower has a mass of 35 kilograms and an effective coefficient of static friction with a value of 0.35 and an effective coefficient of kinetic friction of 0.31. If you push down on the mower at an angle of 35 degrees, how hard do you have to push to move the mower at a constant speed? So static friction is pretty much irrelevant in this problem since the mower is at a constant speed. I'm going to start off by drawing my force body diagram. And so I know we have a normal force, and we also have the force of gravity. And our frictional force, it defined it as kinetic friction. And we push down on the lawnmower at 35-degree angle, so that's our force of a push. So what I did was I put the sum of all the forces equals 0. So our frictional force plus our frictional push x hat equals 0, and our normal force plus the force of gravity plus the frictional push of y hat equals 0. Then I took this first equation, my x equation, and I plugged in what I knew. My known is a mass of 35 kilograms and kinetic friction of negative 0.31. So I got negative 0.31 normal force plus frictional push cosine 35 equals 0. Then I took my y equation and, I think the phone was a little off. Then I took my y equation and let's see what I did. Let me think on. What did I do? Okay, I also plugged in what I knew, and that gave me my normal force plus 35 times negative 9.8, which is the force of gravity, minus my pushing force sine 35 equals 0. I'm getting these 35s from the degrees using my trig functions. So then I simplified it by just distributing, and I got my normal force minus 343 minus force of a push, I keep wanting to say pull, times 0.574, which is sine 35 equals 0. Then I took everything away from this side, put it on this side. So that left me with my normal force equals 343, my pushing force times 0.574. So I'm going to hold on to this equation and keep it in mind, because I'm going to need this equation to plug in for this equation on the next page. Well, I already let you see the answer. So basically what I did was I tried to color code it to help out. So negative 0.31 plus FP cosine 35 equals 0. Then I plugged in Fn to this part of the equation. So then that gave me negative 0.31 times 343 plus frictional push times 0.574 plus frictional push of 0.819 equals 0. Then I subtracted, then I distributed. It gave me negative 106.33 minus my frictional push times 0.178 plus frictional push of 0.819 equals 0. And I added 106.33 to both sides, and that gave me my negative frictional push times 0.178 plus frictional push of 0.819 equals 106.33. Then what I did was I divided, well, after I distributed the FPs, actually substituted, then I divided by negative 0.178 plus 0.819 to both sides, and it gave me this, and I algebraically solved it for 165.8. And that is my problem.